Joanna is wrapping a present in the box shown. Find the amount of wrapping paper in square inches that Joanna needs, not counting overlap. So when I wrap presents, I exclusively use tinfoil to wrap my presents. Make sure there's no overlap at all. Everything looks really nice. I think people who can wrap presents with wrapping paper are using some form of black magic or witchcraft. But let's assume that you are one of those rare people who is able to harness the dark arts and actually wrap a present so that it does not look as though you have dropped it down a flight of stairs and there is no overlap. The way that you figure out how much paper you need to go around a shape like this, and this shape is called a rectangular prism because the bottom of the shape and the sides of the shape are all rectangles, and it's prism because it's three-dimensional, so it's a rectangular prism. We want to find what is called the surface area. And the surface area is the area of all of the outside surfaces. So previously we found the volume, which is how much can fit inside of the shape. Surface area is just what's on the outside. So a rectangular prism has 6 sides. It's got the top and the bottom. Those are 2 sides. Left and right are 2 more sides, and then front and back are 2 more sides. So when we're finding the area of a rectangular prism, there are actually 2 different areas that we have to be aware of. One of them is called the lateral surface area. The lateral surface area is the area around the sides of the shape, not including the top and the bottom. So I've got this. This is a tissue box that Grandma Tay made for me, and so if I were to hold the tissue box like this, let me move back a little bit so you can see the whole thing. If I were to hold the tissue box like this, it's got a SWT on the outside on all 4 sides because that's where I went to college, Southwest Texas State. Go Bobcats. These 4 sides, these outside edges that all have the SWT on them, these 4 sides are the lateral surface area. Now the bottom, where this hole is, this is where you put the box of tissues in. The bottom and the top, this is where the tissues come out. These are not included in the lateral surface area. The lateral surface area are just the 4 outside pieces. So when we look at this rectangular prism here and we talk about the lateral surface area, the lateral surface area is just the front, the back, the left, and the right. It does not include the top and the bottom. So 4 sides only are the lateral surface area. So how do we find the lateral surface area only, just the lateral surface area? Well, the lateral surface area is found by getting the perimeter of the base of this shape and multiplying by the height. So P is the perimeter of the base, and H is the height. Pretty simple. Pretty simple to find the lateral surface area. Perimeter for the base times the height. Okay, well, let's look at this shape here. The base is the bottom. Here it is right there. I want to find the perimeter of that shape. Perimeter just means around the edge there. So we've got a 1 and an 8. And then back here, we're going to have another 1. And back here, we're going to have another 8. And what I notice is that these are all different units. I've got 1 foot and then 8 inches. So I want to make sure I'm counting all in the same unit, either all feet or all inches. It doesn't really matter which one we use. We can convert the inches to feet or convert the feet to inches. I'm going to go ahead and convert the feet into inches for 2 reasons. Number 1, so that I don't have to deal with decimals. Converting inches into feet means I would have to divide by 12 and I'd end up with decimals. Second reason is that I noticed this other measurement here, this 6, is also in inches. So if I convert feet to inches, I only have to do 1 conversion instead of 2. Plus, turning feet into inches is really easy when it's 1 foot, because 1 foot is 12 inches. So this is going to be 12 inches. This is 8 inches. Okay, so the perimeter of my base is going to be 8 plus 8 plus 12 plus 12, which I'm going to write as 2 8s and 2 12s, which is going to be 16 plus 24, which my sources say is 40. So the perimeter of the base is 40. And then my height is going to be that 6 right there. 6 is going to be the height. So that equals 6. So then the entire thing, the lateral surface area, is going to be 40 times 6, which is 240. The unit is inches, and because this is area, it's square inches. Now, this is not my answer because this is just the lateral surface area. It's just the area around the sides. I want to find what is called the total surface area. The total surface area. What is the total amount of paper that I need to wrap this whole shape? I've got the 4 sides that go around the outside, the lateral area. I now need to just add the top and the bottom. Well, the top and the bottom are both rectangles. So the surface area for the top and the bottom, the total surface area, means get the top and the bottom. So 2 times, we're going to say big B for area of the base, plus the lateral surface area. And in this case, big B is going to be area of the base. Well, the area of the base is going to use the same measurements that I used to find the perimeter of the base. Area is length times width for a rectangle. My 2 measurements were 8 and 12, so I'm going to do 8 times 12. And 8 times 12 is 96. So 96 is the area of the base. So my total surface area then is going to be 2 times 96 plus the lateral surface area, which was 240. And whatever that turns out to be, that's going to be the total amount of paper that I need. So fairly large number, but that's all right. 2 times 96, well, 2 times 90 is 180, and 2 times 6 is 12, and 180 plus 12 is 192. And 192 plus 240, what in the world could that be? I have no idea. Don't have a calculator handy. We'll have to do this old school. Don't have a calculator. It's going to be 2, 3, 4, 432. And this is inches. And because this is area, the unit for area is always square units. So this is going to be 432 square inches. That's how much wrapping paper I will need if I wrap this perfectly and there is no overlap. I can assure you, I personally will need at least double this amount because of the number of mistakes that I will make when wrapping this. I will eventually give up and hand this to somebody who knows how to wrap presents. But if you are a present wrapping expert and you can do it perfectly the first try, 432 square inches is how much wrapping paper you will need. Might be more appropriate to just say the surface area of this rectangular prism is 432 square inches, and perhaps you can decide based on your wrapping abilities how much wrapping paper you will need to successfully wrap a box that size.